So we will show two examples to analytically solve an L and U matrices for LU decomposition. Okay, how to construct L and U matrix. Okay, let's make an example. For example, a 2x2 matrices, which is A equals to 2, 8, 1, 7. So we want to find the L and the U matrices for this A system where the A will be equals to L times U. Okay. Then how we do? We basically the LU matrices construction. The key point is we are trying to find what is the elementary row matrices for the A. Then we construct the L and the U matrices based on those elementary row matrices. Okay, so A is 2, 8, 1, 7. We are trying to find its own elementary matrices, which is for the second row. In order to construct this A to be an upper triangular, then you need to convert this 8, the second row first element, the A to 1 to be 0. So you need to find the elementary row matrices to convert this 8 to be 0 in order to have this whole A become an upper triangular. Okay, so become an upper triangular matrices. And what is the row matrices to convert this 8 to be 0? So consider about the scaling parameter, which is the A21 divided by A11, that will be 4. But you need to eliminate this 8, so it should be minus 4 there. And what is the elementary row matrices? The elementary row matrix is basically for the it's basically an identity matrix with a scaling parameter number at that AIJ. You can think about. So we are trying to eliminate this A21, then we should have our elementary row operators with the E21 here to be a scaling parameter to eliminate this 8. So the other element will be identity matrices, which is 1, 1, 0 here, identity matrix. And this number has to be eliminated this 8. So it should be negative 4 times 2 will be negative 8. Add to this 8 will be 0. So that is the elementary row matrices. Then you use this E21 times our A, which is A here, and trying to check if I can convert your A matrices to be an upper triangular matrices. Let's see what is the U11 here. Will be 1 times 2 plus 0 times 8 will be 2. Okay. So the U12 will be 1 times 1 plus 0 times 7 will be 1 here. Okay. Then what is this U21? Will be negative 4 times 2 plus 1 times 8. So it will be 0. Then what is the last element, U22 here? Will be negative 4 times 1 plus 1 times 7 will be 3 here. So you can see that by operating this row, elementary row matrices, we can convert this A to be an upper triangular matrices. Okay. And we also know that A should be equals to, so now it's E21 times A become U matrices. Then if we times e to 1 inverse, so if we times e to 1 inverse, e to 1 times a equals to e inverse, e to 1 inverse times u, right? So both sides we operate e to 1 inverse there. Then e to 1 inverse times e to 1 will be identity matrices. Identity matrices operates on any matrices will be that matrices itself. So it become A equals to E to 1 inverse U. Okay? And you can see that this E to 1 inverse is actually a lower triangular matrices. So this is also a lower triangular matrices times U. So that is how we get our lower triangular matrices and the U matrices. And this L is actually the inverse of U row elementary row matrices. And this L for this problem site will be equals to E to 1 inverse will be equals to 1104. Okay. And you can write this A is equals to L times U. You can try to verify this. Then how about, let's say, how about 3 by 3 matrices? How about a 3 by 3 matrix or n by n matrix? Right? You have this A. You are trying to convert this A to be a 3 by 3 upper triangular matrices. So trying to convert to a U. What kind of operation you need to operate on this A? So for example, you have A matrices, have X A11, A12, A13, A21, A22, A23, A33, sorry, A31, A32, A33. So this is you 3 by 3 matrices, and you are trying to convert this A to be upper triangular matrices. Then what is the row operations you need to involve into the system? So you need to involve this matrix, this element. I will highlight. You need to apply for this element. You need to apply on this element. You need to apply on this element, right? So you need to apply 3 elementary row matrices to convert this A to be upper triangular matrices. And what are those row operations matrices? That will be E to 1, E3, 1, and E3, 2. Okay, so you have the 3 element to convert this A into U. Okay, then let's say this is no pivoting. We are now consider pivoting. Then what is your LU? So A will be equals to E31 inverse times E32 inverse times E31 inverse times E21 inverse times U. Okay, so A will be, you need to apply all the inverse for this elementary row matrices to have this identity times A equals to A itself, and that will be 2 1 inverse, 3 1 inverse, 3 2 inverse times U. And this is U lower matrices, the LU decomposition. Okay, so this is how you convert the A matrices into LU decomposition. And let's make an example. Let's make an example for 3 by 3 matrices. Then you will be more familiar with LU decomposition. Okay, so another example. For LU decomposition, let's say A equals to 8, 0, 6, 0, -8, 4, -6, -2, 0. Okay, so this is a 3 by 3 matrices, and the B will be equals to 7, -1, 4. And let's try to use LU decomposition to decomposite this A to be L and U, and trying to solve this X with this matrices. So AX equals to B. Okay. Then how to convert this A into U? As we said, we need to apply the elementary row matrices to convert the A into an upper triangular. You need to apply E21, E31, and E32 to convert A into U. So what is your E21 first? So this, what is your E21? Your E21 don't need to apply anything, it's already 0. So this E21 is your identity matrices, or you don't need to consider this E21. So the only thing you need to consider is the E31 and the E32. So the E21 can be identity matrices. Matrix, okay? What is your E31? So the E31, we can write as an identity matrices with only the E31 has the scaling parameter. So 1, 1, 1, 0, 0, 0, and then 0. Okay, so what is the E31? The E31 was trying to convert the 6 to be 0. Okay, convert the 6 to be 0. How you convert this 6 to be 0? With the scaling parameter will be 6/8, right? 6/8. And you need to eliminate this 6. That will be -6/8. Okay. E32 times A matrices is 8, 0, -6, 0, -2, -8, -2, 6, 4, 0. Okay. So that is your new matrices. This is the E31. How about your E32? The E32 is here. So you have the 4 here. Okay. In order to have this 4 to be 0, you need to have the scaling parameter is respect to this -8, right? So it's 4 divided by -8. And in order to eliminate this 4, then what you need to have? You need to have the opposite sign of that 4/-8. That will be +4/8. So what is your E32? Will be 1, 1, 1, 0, 0, 0, 0, 0. So this number will be 4/8. And times 1, 0, 0, 0, 1, 0, -6/8, 0, 1, times 8/6, 0, -8, -2, 6, 4, 0. Okay, so this system doesn't have pivoting. Later, if you make a complex system, you need to have the pivoting so that you don't have the scaling parameter is error. So basically, the element is the diagonal element is 0. Then you don't have this LU decomposition. You have to do the pivoting first. But this case is simple. It doesn't have the pivoting. After you apply this E32, E31, where E21 is the identity matrix A, your upper triangular matrices become 8, 0, -6, 0, -8, -2, 0, 0, 7, 2. So this is your U matrix after you operate 31 and 32 for the elementary row matrices. The A become an upper triangular. Okay, what is your lower triangular? The lower triangular, as we solved before, it should be the inverse matrices of E21, inverse matrices of E31, and the inverse matrices of the 32. Okay. And since this E21 inverse matrices will be identity matrices, then here for this problem in particular, it will be just the inverse matrices of the E31 times the inverse matrices of the E32. And in the end, you already know what is the E31 and the E32 matrices. Then you know what is the L matrices. Will be 1, 0, 0, 0, 1, 0, 0.75, negative 0.51. Okay, so this is your lower triangular matrices. Okay, lower triangular matrices.